Okay, so let's summarize what's going on in this lecture. And, it's been a mostly conceptual lecture, not much math and derivations and this and that, but the concepts have been very important. Okay, because overfitting being able to handle overfitting is what separates the expert from the amateur. And we saw certain very counterintuitive things like, if your target function complexity is going up, then you had better start thinking about simplifying the learner. That's very counterintuitive. Okay, you learned it here. Okay, now, just to summarize, you can think of overfitting as a disease. And the virus, what's causing the disease is noise, both kinds of noise. And we sort of gave this general definition of noise as, that part of the data which you cannot model, which the learner cannot model. And in trying to model it, you are led astray. Okay. And you can bet your bottom dollar that in any application you are going to be faced with in the future, you will have measurement errors. You will have stochastic noise. We just don't have perfect measuring instruments for pretty much any application. So noise is always there. And it's pretty much always the case that you will have deterministic noise because the type of target functions that we're trying to learn in complex applications that have big impact tend to be complex. Okay, so there's always noise. Okay, and it's leading the learning astray. And so we need to be able to deal with this. Okay, so we're going to study next, regularization, which is a technique for dealing, it's a cure for overfitting. And we will also study validation. Now, quick summary. So regularization. You're the learner, you have your hypothesis set, and you're fitting the data. You're getting lower and lower in-sample error. But at some point, overfitting kicks in, and your fitting of the data giving you lower and lower in-sample error is resulting in higher and higher out-of-sample error. Okay, so it's time to apply the brakes on the fitting. And that's more or less what regularization does. Remember the overfitting scenarios from the last lecture where we applied the fourth order polynomial, and I posed the question, is it possible to use the fourth order polynomial but not suffer from that weird nonsensical fit? Okay, that can sort of be addressed by this technique that we're going to talk about next, which is regularization. Can we apply the brakes? So then we can get the benefit of a high order polynomial transform, get the benefit of a complex hypothesis set, but be able to apply the brakes to prevent overfitting. That's regularization. Okay. And validation is similar in the sense that it's one of the tools that we have for combating overfitting. Okay, but it does it in a different way. So you're fitting the data, and you're in some kind of a bliss that everything is looking better and better and better and better. But validation comes and gives you a reality check by giving you a peek at the out-of-sample error. Okay, and says, buddy, you might think that you're getting better and better in-sample error, but your out-of-sample error is getting worse and worse. You are starting to overfit. You better backtrack. Okay, so regularization and validation are next. But I want to just give you I want to whet your appetite and show you some of the power of these tools that we're about to develop. And, things might get a little mathematical, but this is to say, stay tuned, pay attention, because noise is everywhere. Overfitting is a disease that you cannot avoid, so you had better build yourself a cure for it. Okay, so you need to understand regularization because noise is always there. You need to understand validation, a very powerful technique, one of which is to sort of combat overfitting. Okay, so here's the data that the learning problem and the data that, started this discussion of showing you this sort of classic example of overfitting. Okay, and then this applying the brakes tool, this regularization tool, I'm going to show you what happens if we apply a teeny weeny, insy bitsy, small amount of regularization. Wow! Look at that. Tiny amount of regularization takes nonsense to nearly a perfect fit. Okay, nearly a perfect fit to the target function. And that's just a little bit of regularization, just to show you how worth it is to study this tool, regularization. Next, checking out.